Moving on to the Grandmaster video for Chapter 2, Section 1, some critical thinking problems. Number 1, the area of Stanley Park, so I have a picture here, in Vancouver, is about 4.05 kilometers squared, or square kilometers. Express the area in hectares, abbreviated as HA. And if you don't know what a hectare is, by definition, 1 square kilometer is equal to 100 hectares. Now notice how this little HA, there's no 3 here. And that's because inherently a hectare is a 3-dimensional measurement. Just like a liter or a milliliter, we don't put a little 3 there because we already understand them to be a 3-dimensional unit. So let's convert this. So 4.05 kilometers squared. And, well, we're given the conversion to hectares. We know that there's 1 kilometer squared per 100 hectares. Okay, so I just copied that conversion, and the kilometer squares, they cancel. Okay, so that was easy. I just multiply my number by 100. So that's 405 hectares. And there we go. Number 2, the area of Central Park. So here's a picture of that in New York City and Manhattan is a bit smaller. It's 3.4 square kilometers. Express this in hectares. That's pretty easy. So this is 3.40 square kilometers. And I'm going to use the same conversion. This is 100 hectares per 1 kilometer squared. Okay, these cancel. So I get, this is easy, 340 hectares. There we are. Number 3, by area as a percentage, how much larger is Stanley Park than Central Park? So our final answer, we want to express this as a percentage, but before I do that, let's just figure out how much larger it is. So I know that 405 hectares minus 340 hectares, if you work that out, you get, let's put it in my HA here, that gives us 65, I think, hectares. Okay, so in other words, Stanley Park is 65 hectares more or larger than Central Park. So we want to figure out what is this number as a percentage of Central Park's area. Now you've all done this before. Whenever you've gotten a test back and you want to figure out what you got as a percentage, you simply take your test score and you divide it by the total. Well, it's the same thing here. So this is 65 hectares divided by the initial area of Central Park. Of course these cancel because we're looking for a percentage, and a percentage doesn't have units. So 65 divided by 340, and we get approximately 0.19. Okay, well, this is a decimal, so if you express it as a percent, you should be familiar with how to do that. That is 19%. Okay. So if you increase the area of Central Park by 19%, you will get the area of Stanley Park. Or, said differently, the area of Stanley Park is 19% larger than the area of Central Park. Number 4, express the area of Central Park in acres. Okay, acres is just another way of measuring the area of something, typically something that's large. But we're given the conversion that 1 acre is equal to 43,560 square feet. Okay. Now we already have the area of Central Park using 2 different units. We worked with hectares, and we originally started in square kilometers. Well, in order to get to acres, I need to go to square feet, and it's probably a bit quicker to start with the area in square kilometers rather than hectares. So I'm going to go back to my original measurement. So this is 3.40 square kilometers. That's the initial area of Central Park that I was given. And now I'm going to work my way to feet squared, because that will take me to acres after. So from kilometers, okay, I can go to meters. So that's 1 kilometer per 1,000 meters. There we go. And then from meters, I can go to centimeters. So just watch where you put them. And then I can cross over to the imperial system. So this is 2.54 centimeters. And this is an inch. And now I can go to feet. So 12 inches per foot. So now I can go to acres. So I just got to be careful here, because don't forget, before I actually work this out, I have to square all of these. So feet, so this is 43, 5, 60. Remember, this number is already in square feet. So these are already squared. So I'm not going to square this. I don't want to do that. Okay, and that's 1 acre. Okay, so I need to square these. So therefore the numbers I square, these all get squared. Huh, it's kind of tedious. Okay, make sure they cancel, 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 cancel. Okay. All right. Let's take our calculator and work out this mess. All right. I get approximately 840 acres. Okay. That's roughly how large Central Park is. Number 5, what is the area of Stanley Park in square feet? Express in scientific notation. What on earth is that? So first thing I'm going to do is just express this area in square feet, and then I'll explain what this scientific notation is. Okay, so I've actually already done the conversion, so you're welcome to pause the video and get these down if you like. So I'm just going to ensure that all these units cancel out properly. Okay. So if you compare this to the one above, it's virtually identical. Of course, I'm dealing with Central Park, so the number is changed to 4.05 square kilometers. But I didn't have to go to acres as I did before, so I was able to stop at square feet. So there's one less conversion factor in this line. So when you work out this number, it's not particularly nice. Okay, you get a lot of digits, and I'm going to actually cut off some of these digits. They're not really relevant, and you're going to learn about something called significant digits or significant figures next year. But the measurement that I had, really there are only 3 numbers that are important, and even in these conversions, okay? So when I write out this number, it's approximately, I get over 43 million, so I'm going to round it, and I'm going to round this to, well, let's say 43 million, 600,000, let's say. Okay, and of course this is feet squared. Okay, so this is approximate, but it's enough digits for as accurate as I want to be. There we go. All right, now what does it mean to write this number in scientific notation? What is scientific notation? Well, scientific notation is just a way of expressing numbers, particularly numbers that are very large or very small, or numbers that have just lots of zeros in it. Because if you end up taking chemistry or physics and you deal with numbers like this, you'll discover quite quickly that it is very tedious to have to write out zeros all the time. So scientific notation is just a shortcut to save us from having to write them out. So in a nutshell, here's how it works. Okay. I have 43,600,000. But believe it or not, there is an invisible decimal place right here, which normally we would not write. So what I'm going to do is I'm going to shift the decimal until the number that I have is between 1 and 10. Okay, so it's going to have to stop here between the 4 and the 3, because then I'm going to have 4.36. But every time I shift the decimal place one place to the left, what I have to do is multiply it by a power of 10 each time. So here's what's going to happen. Right. So this is going to travel 1, 2, 3, 4, 5, 6, 7 places, and I'm going to stop there because the number that I have is between 1 and 10. Okay, so this is going to be 4.36. Okay, now how many times did I shift it? We shifted it 7 times. Okay, so we write times 10, okay, because really when we're ever shifting a decimal, you're just multiplying it by 10, and I raise that 10 to the power of 7. And of course this is still in feet squared. So these two numbers are exactly the same, only this is written in scientific notation. And as you can see, I didn't have to write so many zeros. Okay? If you're a little confused, that's totally fine. The best way to become more comfortable is just to do a bunch of examples. And that's what I'm going to do for number 6. Okay. Number 6, express the following numbers in standard scientific notation. Well, I said scientific notation. What does standard mean? Okay. Well, I'll explain that particularly with these last two. Here I have 813 million. So I have 813 followed by 6 zeros. Now, you may want to write all those out, but yeah, I don't really feel like doing that. So, of course, the decimal is here. It's just invisible right now. So what I want to do is I want to shift the decimal so that my number is between 1 and 10. So it's going to have to stop right here. So I'm going to get 8.13. So count how many places. 1, 2, 3, 4, 5, 6, 7, 8 spots. Okay, so this is going to be 8.13. And my decimal, I had to shift it to the left 8 times. Okay, so 8.13 times 10 to the power of 8, or times 10 8 times, is equivalent to 813 million. All right, let's look at the next one. Here I have a very small number this time. I have 0.00000000175. Okay? Kind of a pain if you have to write it all the time. So let's put it in scientific notation. So all I want to do is shift the decimal, but in this case I have to go to the right, so that my number is between 1 and 10. Remember, it's always between 1 and 10. So I count 1, 2, 3, 4, 5, 6, 7, 8 places again. So this is going to be 1.75. But the only difference this time is I had to move the decimal to the right 8 times. So it's times 10. But because I had to move the other direction, I write minus 8. Okay, so 1.75 times 10 to the minus 8 is equivalent to this ugly number here. Okay, so this next one touches on what is meant by standard scientific notation. Because if you look at this number, it already appears to be in scientific notation because I have times 10 to the 6. But it's not standard because notice this number here is not in between 1 and 10. 0.03, that is smaller than 1. Okay? So if I want it in standard scientific notation, it has to follow this pattern. Okay, this number here has to be larger than 1 but strictly less than 10. All right? So as is, here's my decimal. It's going to have to shift 1, 2 places to the right. So just like this one, I had to shift it to the right, but this one was 8 places. So this is going to become 3 times 10. Okay, but when we shifted it to the right, in this example, 8 places, this became a minus 8. Okay, so if I shift it to the right 2 places, okay, this would have to decrease this number by 2. So this is going to be times 10 to the 4. Next one, 60.3 times 10 to the power of minus 5. This is a type of scientific notation, but it's not standard. Okay, I need to shift this decimal 1 place to the left this time. Okay, and as we saw in this example, every time you move this decimal to the left, this little exponent here increases. It goes up, gets bigger. So this is going to be 6.03 times 10. But I already had a minus 5, okay? So this number has to go up. It means it has to get bigger only by 1. So now it's to the minus 4. Okay? So these two numbers are exactly the same. They're both in scientific notation, but this is using standard scientific notation. Okay? If you find these two a little bit confusing to work with, don't stress about them. Really, for the time being, these two, those are the more important ones at this stage.